Hi everyone, welcome back to Power BI series. This is lecture 5. In the previous lecture, we have seen some advanced data analytics in Power Query Editor. In this video, that is lecture number 5, we are going to talk about DAX. Okay, we will talk what is DAX. We are going to mainly cover these four topics: measure versus calculated columns, row context, filter context, and we'll see some functions like all and percentage of total, which we are going to remove for the filters. Okay, so let's get started. So in order to create this video, I have connected these data sources. So I have four tables total: sales, product, customer, and calendar. I have already loaded them inside the Power BI. Let me go and show you this. Okay, so when I go to table view, you see this is my calendar table and we have this date, year, month, and quarter. Okay, when you go to customers table, we have this thing: customer ID, customer name, region, and segment, right? And you see, like, headers are not coming properly. We have this customer ID, customer name, region, and segment, and above that we have columns. So maybe we can go inside the Power Query and use first row as header so that we can get proper headers. Let's check other tables. We have product tables. Here we are getting the product ID, name, category, and unit price properly, and in the sales also this is proper. Now what I'm going to do, I will go to once again here and I will say transform data, and I will click on this. Okay, so it's going to load the Power Query Editor, so just wait for it. Alright, so now we are inside the Power Query Editor. Now the problem was in the customer table, so I will select it, and here I will go to transform and I will say use first row as header. I will select this, and as soon as I did this, see, customer ID, name, region, and segment now becomes this. Now I will go to home and I will say close and apply. Okay, that's it. We don't require any other transformation or any other data cleaning stuff over here. That's it. Now these four tables, they have relationship, and when I go to this model view, let's come to the model view, and now you see what relationship we have. Okay, so this is our main table, that is called a sales table. In the sales table, we have all the unique keys which are present in different other tables. For example, sales table have this customer ID, which is available inside the customers table as well, the customer ID. So we are going to map this table, both this table, connect these tables with the help of this customer ID key. Similarly, when you see products table, we have something called as product ID, which is also available inside the sales table. And same goes with calendar. We have order date and date. Okay, now these two tables are already being identified by Power BI and they have connected it, but this calendar table is yet not connected. So let me connect this. In order to do it, you need to first identify which columns are or which fields are common. So this date and order dates are common, so I will drag this date inside the sales order date, and that's it. When I do this, see, it is now able to identify this date and order date properly. And when you see cardinality, it is saying 1 to 1. Now we will come to this point, what is cardinality. Okay, and if you see this cross filter direction, it is saying both, meaning you can do filtering from one table to another table, also from another table to first table. So I will save this, and hooray, now we have all the tables connected to the sales table. Now what kind of schema this is? In the previous session only, I have shown you this is called as star schema. So this is our main fact table, and these are the dimension tables we have. Let's suppose if you connect your product table to another dimension table, right? For example, if you miss any information in the product and you create another helper table basically for this product table, so that will becomes the snowflake schema. So in the snowflake schema, you will have dimension table of dimension table, right? But right now we have connected into the star schema fashion. Now what I will show you, I will go to the table view, or before I go to table view, let's talk about this. When you double click on this relationship, you see one-to-one relationship is here between sales and calendar. Cancel it. When you see, click over here, you see here also you have, now you have many to one relation between product and sale, and when you click over here you have one-to-one relation. So let's talk about what is this one-to-one and one-to-many relationship. For that I have already prepared one PPT, so let me show you. Okay, so you see we have cardinality, right? Now what is meaning of one-to-one? So one-to-one meaning one row in table A matches exactly one row in table B. There are no duplicates on both the sides or both the table. Example, if I give you, you see we have this table employee ID name, employee ID as E001, E002 and names. And we have another table called as employee payroll with the employee ID and bank account. Here also you have employee ID E001 and E002. Now both the tables have unique employee ID. There is no repetition, and that's why when you are going to connect these two tables into the Power BI into the data model view, you will see a one-to-one relationship because they have unique values in the employee ID, and we are going to connect them with respect to employee ID field only. So this is going to make one-to-one relationship, right? So this relationship is one-to-one. When we use it, you know, when let's suppose if you split sensitive data, for example HR versus payroll, or if you want to perform the optimization, in that case we use this one-to-one relationship. Okay, so in many scenarios you can see all the tables will have some unique records, but this is very rare. In real world scenario, you know, in the dimension tables you will have, you know, a unique key, but in the fact table you will have repeating thing, right? So that is how the real world scenario looks like. But yes, if fact table and dimension table both are having unique, in that case one-to-one relationship is followed. Next we have something called as one-to-many relationship. So as name suggests, one row in table A relates to many rows in table B. Okay, this is default and recommended. Example, if I give you, see we have this table customers, we have the customer ID 01 and 02. Then we have sales table where we have sales ID as the primary key and then customer ID as a foreign key, right? So when you say foreign key means this field is going to refer in this particular table, and this is the primary key. When you say primary key, so that is the unique identifier for that particular table. Okay, now here if you see customer ID, we have 001, 001 and 002. So here we have customer ID repeating. So that's why this many customer, right? One customer can appear many times. So that's why this is called as many, and that's why relation is one to many, right? Now when we use fact and dimension modeling inside it with we use this kind of thing, and in the real world scenario also this kind of tables actually appears. Okay, now this one of the rule I have written over here, dimension are always on the one side, facts are always on the many side. What is the meaning of it? For example, if you go to here and let's talk about this product and sale, let me click on this. You see we have many to one relation. So which side we have many? You see small star over here written and one written over here. What is sales table? This is our fact table. What is product table? This is our dimension table. So on the fact side this many always comes, and in the dimension side one always comes. So that's why we call it as many to one. Now, or one to many also, if you see one to many, it's just opposite of many to one. Now when I come over here, see this is the thumb rule. Dimension are always one side as I shown, facts are always on the many side. Now if we talk about third option, which is many to one, this is going to be same as one to many, but in Power BI you see this option only, many to one. Okay, so it's just the opposite of it, but Power BI by default shows you many to one relationship only. Okay, so you can just consider a vice versa, nothing more. Now last we have something called as many to many relationship, right? So here we have this um, many to one, and yeah, this one is many to many. Now in many to many, if you see, we have this table student id course, and then we have teacher and course. Okay, and so basically what will happen, many fields or many, here I have taken a wrong example, but you can consider this as, many students are enrolling in many courses. Similarly, many teachers are teaching many subjects. So this relationship we call it as a many to many. Same information can appear multiple times, but this is dangerous. We don't use this in real world scenarios. This is kind of going to create a duplicate data more and more, so we avoid this kind of table creation. I have written you can say overview of it in one-on-one or one-to-one. This is very rarely used. One to many is best, many to one is normal. So you can use one to many or many to one, that's not a problem. This is how real world scenarios happen. And many to many is complex mapping, we avoid this kind of mapping, right? In real world scenarios we don't we rarely have this data, but all these scenarios exist, and in some cases you can get one to one or many to many as well. So that's why it was necessary to teach all these four concepts to you. So now you understood, we have all this relationship established in the data model view, and this is what we do inside the data modeling, right? We create our fact table and dimension table with respect to different cardinalities, right? And we have 4 types of cardinality. Great. Now if you have understood this properly, so what I can do now, I can come to report view, and now we can talk about DAX. Now what is DAX? Let's start exploring this. So first of all, DAX is nothing but it's just a formula, or you can say a programming language with the help of which you can write create some measure or create some calculated fields inside the Power BI. Now what is measure and what is calculated column or fields, we will come to it. Now let me just zoom this little more. Okay, now here as you can see, or we can do in this way. All right, fine, this is fine. So you see, whenever we start DAX inside the Power BI, student always thinks that DAX is it's all about formula. If they understood the formula, DAX is done. No, that is not how DAX is done actually. DAX is about controlling the context. Okay, it's not about controlling the formula or knowing the formula, it's about controlling the context. What is the meaning of it, context? Let's understand it. So in the Power BI, we have 2 type of context. We have something called as raw context, and then second is something called as filter context. Now let's understand first what is context. So you can understand or imagine this like you are seeing the data. Okay, now let me just take this. What I can do, I can maybe take an example of table. So you see, we have this table, okay, for example, and right now let's suppose you are seeing only these 2 rows. So whatever you are seeing right now, we call it as a context. Okay, so basically, for example, context meaning is what? For example, if you take example from the English. So let's say if I say, hey, I watched the movie Chris 3, so and then finally I loved it. So when I say then finally I loved it, so it was referring to what? It was referring to Chris 3 movie. Similarly, context is what? Context is nothing but in the Power BI, in terms of Power BI, whatever data you are seeing, that is called as context. Whatever you are talking about the data, current data, we call it as a context, right? Context of the data. So we have 2 types of context, raw context and filter context. In raw context, current row being evaluated, meaning for example, if you have a table and you are seeing the row context. So row context means now you are not seeing the whole table, but you are focusing on a single row. Okay, one single row. But when I say filter context, meaning which rows are visible due to slicer, filter or visual. So filter context means, so you can understand this, filters means you have a table, you applied a filter. So let's suppose earlier you have 100 rows and now you have 50 rows. So filter context means now you are only seeing or talking about those 50 rows. So that comes under the filter context. Now these two terms are backbone of understanding the DAX. That's why I given more stress on this. What is row context and what is filter context? Let's summarize it once again. Row context is nothing but row wise evaluation. Filter context means you have applied some filter and now you are only seeing the filtered rows. That's it. Okay, so now let's talk about this measure versus calculated columns, row context, filter context and all. We have already understood the theoretical meaning of row context and filter context, but now let's understand what is measure and calculated columns. So I will first show you inside the UI what is measures and what is calculated columns. So you see you have something called as new measure over here, right? So what is this measure? Let's understand it. So okay, and even before understanding the measures, I have written the first calculated column. So let's go and show you what is calculated column. So whenever you go to this table view, you will be able to see this new column feature also, right? See, we have new column. So what is this new column meaning? So whenever you create a new column, what will happen, that column will be stored in the physical layer. First let's understand this. It will be stored in a physical layer of Power BI. That means it is going to occupy some memory inside the RAM. Okay, that is the first thing about new column. So whenever we create new column, it will hold the data, it will have some physical space in the entire memory stack. So now let's come over here. So what is calculated column? It evaluate row by row. First of all, that is also true. It takes some space in the RAM. That is also true. Calculate at data refresh. So for example, you have created a calculated column and you have changed your actual column, actual data for example. But if you haven't refreshed that data, it will not be reflected into your calculated column. You have to refresh your original data, then only it will be show. It's stored in memory. So as I already talked about it, it is going to take some storage inside the RAM, and it does not react to slicers. Okay, now what is the meaning of slicers? Slicers are nothing but filters. It does not react to slicers. This point is not completely true. I will show you. Now what are measures? So let's talk about them. So as I shown you here, you have this new measure or quick measure, both are same. Now you see measures are nothing but these are also kind of calculated column or field only, but they are not going to take any storage inside the RAM. They are evaluated at runtime. So for example, you create a measure, you close your Power BI, so it is not going to hold any space in your memory. When you load your Power BI, and at that time when you are going to drag and drop the measure, let's suppose you created a measure, it will appear over here. Now it is not going to take any memory, it is not going to hold any data until and unless you are going to drag and drop it inside the report view. So it is going to be evaluated at a runtime. So when I say runtime meaning you drag and drop it over here, then only whatever formula or whatever DAX query you have written, at that time it is going to be executed. But when you create a new column, it is going to execute it at that time only. It is not going to be executed at runtime. So that is the difference between measure and column. Okay, now let's come over here. So same thing I have written, evaluated at query time, respond to filter and slicer, not stored in memory, and prefer for analytics. Okay, now let's take some example so that we can clarify this properly. Now for example, I need to create a calculated column called as product revenue. Okay, and for that I'm going to use this formula. Let's say I will say row sales amount. Okay, I'm going to create this. So I'm copy this formula and I will go here. I will create a new column. So just click on this. So see one bar come over here where you can write your DAX query. So you just paste this. Now what this say, row sales amount, this is my going to be the name of the column, equals to what I want from the sales table. So I have written sales and unit sold. So from the sales table select the unit sold, this thing unit sold, what unit sold column, and multiply it to product. So go inside the product table, we have this product table, see. So go inside the product table, and inside the product table we are grabbing the unit price. So we have this unit price. So multiply unit sold by unit price. Now when you multiply unit sold and unit price, what you are going to get? Obviously you are going to get the sales amount, right? So but if you see, I have written a related function also over here. Now what is related, I will talk about this in later video also, but just for a overview, I will say that related is nothing but it's going to do the calculation at each and every row level. Okay, this formula, entire formula which we are using, this and this, they don't have power that they can work on a row level, but related have this power. For now you can just understand in this way. I will talk it about later. And since we are using this related, now you see we are able to see this new field row sales amount, and in each and every row we are able to see the data, right? So for sales ID is S001, row sales amount is 225. How we are getting it? We have unit sold 5, and from here we will have some unit price, we are multiplying it, and due to which we are able to see this number 225. And this is happening for each and every row, right? So we have created one calculated column, and this is taking memory inside your RAM. It is occupying some memory. All right, let me click OK. So this is we created. Okay, now let's take one more example. I will this time I will create a measure. Okay, so let's say I want to see the total sales, overall sales. Okay, here if you see, if you are going to add all these things, right, add all these things, you will be able to get the overall sales, right? That is the first thing, you can do it. So in order to do it, I will go over here. Now total sales, this, why this should be a measure and not calculated column? Just think about it. Calculated column, why? Because see, if you change your data, right, if you change, for example, if you add more rows, so obviously your total sales is going to differ. So in that case, do you want to store it in your memory, or do you want to calculate it at runtime? Obviously runtime, right? Because you can add or change these numbers may change, or you can add some extra rows also. So in that's why this should be a measure. So in order to create a measure, you can click here also, or if you go to table view from here also, you will have the option. When you go to home, you will have the this new measure. So let me click here and say new measure. Now let's say I will give the name as total sales, and that is going to be equal to, now this is measure I am creating. Okay, now we have already created this row sales, right? Row wise sales we have already calculated, right? What's the name we have given? Let me just track this row sales amount. So what if I say directly, there is a formula called as sum formula. So I will say sum of, and here I will directly put this row sales amount. So I will say row sales amount, and this is available inside this sales. Okay, so this particular column which we have calculated, it is available inside this sales table. So that's why it is sales of row sales amount. Let me click OK, and as soon as I do this, you see I got this total sales, which is, you see the difference here. We have like this is coming as a calculator option, that because it is a new measure. This is not a column, right? So now if I drag and drop it over here in the visual and hover my mouse, you see we have total sales of 5640, right? So this is how you create your measure inside the Power BI. Okay, now I will show you the another example, or you can say another way with which you can again see the total sales, and that example is this. So this time I'm going to, instead of using the sum formula, I'm going to use something called as sum x. Okay, so let's use this particular formula, sum x, and let's create one more new measure, and this time I will use this different formula, and let's give the name as total sales equals to. Okay, I have written, okay, let me give in this format, total sales. Okay, now you see this time I'm using sum x formula, and I will explain you what is the difference between sum and sum x. Okay, now here in the sum x I am writing first the table name, that is sales, and then within that table name I am taking the unit sold, and then I'm writing related, which is again going to iterate and going to since we have made the connection between product table and sales table, related function is going to help me to iterate through each and every unit price of the product table and going to multiply with this. So that's why I'm using related, and then we have this unit price, so I'm multiplying this. Okay, now when I say okay, and this is available, when I drag and drop it over here, you see this is the same value. We have taught sales same as total sales. Now you might ask, okay, then what is the difference between these two formula, sum x and sum? Now let me give you one more example. Now this time what I will do, I'm going to create a new measure once again, and this time I'm going to use this, let's say I will say this total sales 1 equals to, and this time I'm going to use this sum formula. Now you just think whatever we have done in this total sales, this particular measure, right? Let me click on this, and you see we have this total sales. Let me double click on this. You see this formula, we have total sales equal to summation of sales of row sales amount, and in the row sales amount we have individual amounts. And if you go to this row sales amount, double click on this, you see what we have done, we have taken the unit sold multiplied with the unit price, right? So if I go to this once again, this formula, see what I'm going to do in this summation, I'm going to take from the sales table, I'm going to take unit sold, and I'm going to multiply it with, from the product table I'm going to take the unit price, right? So I'm multiplying it, and that is how I'm going to get the total sales, right? And I'm applying the sales formula, and as soon as I do this, I will say okay, and you see what error I'm seeing. It is saying the sum function only accept a column reference as an argument. Okay, so you might argue, okay, let's provide here into I will say related function, and within the related let's pass this. Okay, and I will say okay. Now even if I do this, it is giving the same error, the sum function only accept a column reference as an argument. But as soon as I change this formula with sum x, okay, and here I just provide a sales comma this, it is going to start working. See, this is same formula we have used earlier. You see, I can show you. See, sum x sales and then this. Now you may argue, okay, let's remove this x and then use sum over here, and let me do this once again. you see now it is saying too many argument. That means sum doesn't take this sales argument, it only takes this one. So let me remove this. That was the error, but still there is error. So what this error is saying, let me click on right click. Now the error will change. So this is saying that sum only accept a column reference as an argument. What is the meaning of it? Meaning is sum cannot work on a row level, right? Even though related is going to first go and relate our sales with the product and going to work individually on a row level, some function doesn't work on a row level, and that's why we need sum x. Okay, but let's suppose if you have this row sales amount, for each and every row you have calculated the amount, then you can do the normal summation of all the amounts, it will work. But if you have from multiple tables, if you want to do the aggregation on a row wise level, sum won't work. That's why we need sum x. So how this was working, see here in this first way, we have used some formula, but we are saying sales of row sale amount. So it is going inside this calculated field, and it is doing summation of entire field. It is not going row by row and then doing it. It is taking all the things and adding it in just one go. So that is how sum work. But sum x can iterate, so it is a iterator, it can iterate through each and every row. Okay, and that's why sum x was working. I hope this is now clear, right? All right, so here is the, you can say, summary I have written. Calculated column do not recalculate, that is the first thing. Calculated column, we have created one calculated column which is this row sales amount, so it doesn't recalculate unless and until we refresh the data, right? Once you have calculated field, you store the data, that's it, done. But Power BI can still filter row where these value exist, whereas measure recalculate at logic itself. So if you apply filter, it is going to work on the calculated column as well as the measure, if you apply the filter. But the difference is measure recalculates the logic, as we have discussed. Whenever you create a measure inside the Power BI, it is going to work on a runtime, so it will recalculate again and again whenever you drag and drop that field inside the view, else it is going to keep ideal. All right, so that was the measure versus calculated columns. Now let's move toward the next topic, which is row context and iterators. So we have already seen this sum x. Similarly, we have average x, min x, max x. These are the formulas. Now what is row context? Let's understand this. Row context means DAX is evaluating one row at a time. The definition we have already seen. So you can think of it as a current row pointer, right? For example, if you have this table, now when DAX is in row context, it evaluates row 1, then row 2, then row 3. If it is in a row context, meaning row wise row calculation is going on, right? So you understood why here our sum failed and we have to use sum x formula. And if you are using the sum formula, then you need to have one calculated column where already sums are present, right? Then only you can use this sum formula. So that we have already understood, right? Now we need to also understand what are iterators. So iterators, when I say iterators, are nothing but they can create row context automatically. Remember, we have only two contexts, row context and filter context. So whenever you want a row context, meaning you are looking just one row, in that case you need a iterator. Okay, so iterators are basically can create a row context automatically. Okay, and they can go row by row, they can evaluate an expression, and then they can aggregate the result like sum x. So these are some iterators we have: sum x, average x, max x, min x, the example which I was talking about, right? All right, now if you see how this works, this example which we have taken, this sum x sales one example, right? How this works basically, see, so sum x basically nothing but it's an iterator. So it is going to iterate over each row of sales, because we have written sum x of sales. So we have sales table. on the entire sales table, SumX is going to iterate one by one, right? Then we have something called as sales of units sold, right? This one, sales of units sold. So from the sales table, we have one column called as units sold. So it is going to refer the unit sold of a current row, right? Because SumX can iterate through row by row, we can grab each and every row. So from the this particular column, we are going to grab the first row, and then we are using this related. So remember I said I'm going to talk it about later. So this is what we are doing. Related is basically going to fetch price from the product table. And why we have to use related? Because we have a relationship between sales and product table, right? Remember in the modeling view, we have connected these two table. So what is happening? Basically we are connecting this sales table with product table, and related is going to grab the data from this product table. And within the product table, what data we are grabbing? We are grabbing the unit price, right? And unit price, since we have used SumX, it is going to take row by row, and then we are multiplying it simply and returning the result, right? And SumX also going to aggregate the data finally, so you are going to see the whole data, right? So basically related works only when row context exists. Remember this. Related, this particular formula which we have used, related, this is only going to work when we have the row context available and not the filter context. This is very important, okay? Remember guys, whenever we this point is you need to remember, because this, you know, you are going to make this kind of mistakes when you write DAX queries. So whenever you have row context available, then only this related function or related formula works. Else if you have the filter context, meaning you are seeing the, you know, let's suppose 10 rows at a time, then this related function you can't use it. So that's why related was not working with sum, but it is working with SumX. All right, now, and also yeah, there are some things are written over here. It works in the calculated column, it works inside SumX, right? It fails in the plain measure without iterators. So since sum doesn't have the iterator, SumX is iterator, that's why it was failing, right? So yeah, and this is the summary of row context and filter context, right? Now let's talk about this filter context and calculate little bit, okay? Now what is filter context? We have already seen. Filter context is nothing but set of rows that are visible because of, you know, maybe slicers, filters, row column individuals, or page report filters, right? Any kind of filters or slicers. So right now you understood what is filters, but if you're not able to understood slicers, so let me first explain you the slicers. So when you go to your visual, and in the visual you see this is the visual, you hover your mouse, this is called as slicer. So slicers are also nothing but filter only. Let me show you one example. I click on this, so this kind of slicer will appear over here. Now let's say I want to create a slicer or maybe filter for, you know, if I go inside the product, we have category. So I drag and drop category over here. You see now how many categories we have: accessory, devices, gadget, gizmos, and tool. Let's say if I click on tools, now as soon as I click on these tools, you see the data for this and this also got changed. We have 660 total sales for tools, right? And when I uncheck this, you see we have total sales of 5640. So this is called as slicers. They are nothing same as filters only, okay? That is the simple concept, but you can create this slicer with the help of this particular icon. Cool. Now let's come over here. So that is the filter context we understood. Now let's take an example of you know, I have already given the example as well. All right, now what is calculate? Okay, let's understand this function, calculate function. So calculate is a function we have inside the Power BI which can modify the filter context. Okay, remember this. This can modify the filter context, meaning if you are in the row filter, it can go to if you are into the row filter, it can go into the this sorry, if you are into the row context, you can go to the filter context with the help of calculate, and if you are inside the filter context, you can come back to row context with the help of calculate. So it is this. So you can think of it as a recalculate this expression under a different filter rules. Let's take an example. Let's say I want to see the enterprise sales. Okay, so show me sales only for enterprise customers. So if you go over here, you see we have different type of customers. Here we have the segment. If I drag and drop it over here, you see we have two segment, enterprise segment and SMB segment. So I only want to see the sales of, sales of enterprise customer. For example, I have already drag and drop this. Now let's say if I put total sales, I have this here, total sales. You can drag and drop it over here. Now you see for enterprise we have 2565 as a sales. For SMB we have 3075 as a sales, and I only want to see the sales for enterprise. Okay, so one thing, like you can apply a filter over here, right? This is one way you can do it. So for example, you go over here and then take this segment, maybe let's say create a slicer and then put segment inside it, drag and drop it over here, and let's click on enterprise, and see now it is, you are able to see it for enterprise. But same thing I'm going to show you with the help of DAX query. So let's write it. So I have written over here, calculate is going to work in this way. The syntax is this: it will take one expression followed by filters. So you can not only give one filter, you can provide multiple filters also. So let's use this particular formula. So I'm going to copy this and I'm going to create a new measure. Now see why this again going to be measure, because I don't want to save this into my disk. I want to be calculated at runtime, so that if any data will change, this enterprise or SMB, it will change, right? So that's why it is going to be the new measure. So let's click on this and put the formula. So see what it say, enterprise sales equal to calculate, and inside the calculate what we are passing total sales first. So we have already calculated this measure which is called as total sales. So this is another measure, we are using another measure which is total sales inside it. So that was the expression, right? You can not only pass the measure, you can pass any expression. So this is expression we are passing for total sales, and then we are passing a filter. And what is the filter? We are saying customer segment should be equal to enterprise. That's it. And we are saying calculate. Now I will talk in a bit later how it is going to work internally, but let me commit this. And you see we have enterprise sales. Let me drag and drop it over here. Okay, enterprise sales maybe here, and as soon as I do this, just hover my mouse, you see I have 2565. I can clearly see it, right? So same thing I have done with the help of DAX query. Now let's go and understand how it internally works. See, so we have this visualization created, right? Now let me show you. Yeah, okay, let's take one more example, example number 2, with the multiple filters, and then maybe I can show you how it works. So let's say region is south, but we want always show north region sales. Okay, so what I will do, I'm going to copy this query. This is not a multiple filter example, this is normal example. I'm going to copy this and I'm going to create another new measure. Okay, Control V. So see, I want to only see the north sales. Okay, so that's why I created this measure where I'm saying total sales we have, and from the customer I just wanted to see the total sales of north region. let's click on this. So this north sales got created. Now let me create another page. This page was full. Now I'm going to drag and drop this over here. Hover my mouse. You see, for north I have only 1 2 2 5 sales. Now let's say if I want to see sales for each and every region, so what I can do, I can drag and drop region over here. So we have 4 region, and let's put this total sales over here. So you see, I can verify this for north 1 2 2 5, right? So for north 1 2 2 5 we have. Now let's say if I put a slicer or filter, I click on slicer or filter, both are same actually, and I'm going to put this region inside this. And now you see, if I select east, do you see from here it is only showing me for east, but when I hover my mouse over here, see, it is still showing me for the north, even though in the slicer I have selected east. And why is that? Let's understand this. Because you know, we are using this calculate, and inside the calculate we have set our filter as north, so this can override the slicer selection. So calculate has this option, it can override the slicer selection. Even though in the slicer we are selecting east region, it is overriding it, because we have already fixed that we are only want to see the customer region equal to north, right? So basically calculate replaces existing filter on region. It has higher priority than slicers, right? Now let's take one more example. I'm going to only see the enterprise north sales. So this time I'm going to copy this. Now I'm going to apply 2 filters. One filters for the segment enterprise, another region north. So let's calculate this once again, a new measure. Let's put it. So this time I'm saying total sales is my thing, and I want to see, and I want to apply a filter on customer customer segment and then customer region. Let's click OK. Okay, so we have this enterprise north sales. Let me put it over here. So you see, it is only 345. How we can confirm it? Very simple. You take this first region. Let me put region over here. Okay, and I'm going to unfilter this. So we have all the regions. Now I'm going to take the segment, drag and drop it over here. So you see we have all the segment, but wait, we want enterprise only, right? Yeah, so that is fine. And then what I need total sales. So I'm going to put this total sales over here. All right, now you see for enterprise north, right? So for enterprise north it is 345. When I hover my mouse over here, see, it is coming as 345. So this is how I can see it and verify it. Now, so this visualization we have created. Now this is what we need to understand. Slicer sets context, calculate changes the context, and measure reacts to that context. So since we are using the calculate over here, see, for this north sales or for enterprise north sales, even though, you know, if you change, let's say, slicer to maybe east, see, all the things are gone. But here, since we were using the calculate, it is not changing, because calculate changes the context. So it change the context. Slicer set the context, so slicer said east, but calculate changes the context, so it changes to north. And measures react to the context, so whatever measure you have created, it is going to work accordingly. Okay, so that was the case over here. So you understood how this calculate is working. Calculate is working on the entire data set, right? And it is changing the context. If you are in a filter context, it is changing to row context. If you are in a row context, it can change to filter context, right? Now let's come to the next topic, that is all and filter removal. So till now we have talked about filters, how we can change the context, what is row context, what is filter context. But now let's suppose if you want to remove some filters from your data, sometimes we require this, right? So that's why we need this all and filter removal. So let's talk about this, why filter removal is needed. So by default, let's suppose if you have slicers, visuals, row columns, or filter the data, but sometimes business questions need ignore some filters but keep others. So for example, if you have 10 filters but business requires you need to remove 5 filters and keep 5 filters, in that case this things is required. Okay, so what does all do? All remove filters from specified column or table. So in the all, let's suppose if you have 5 filters, if you apply all to 2 filters, so it is going to remove the 2 filters from the 2 column or 2 tables, right? So this is how syntax, when you say all table, it is going to remove all filters from the table. If you say all column, so it is going to remove the filter only from that column. When you say all except, it remove but keep some filters. When you say all except, so here you pass which thing you need to accept, right? When you say all selected, that means it is going to keep slicer context, right? So it is going to keep slicer context, but it is going to remove all the filters, but slicer context will be remain, right? When you say all selected, right? Cool. Now let's take some of the example. Let's say I want to see percentage of total sales, coming from different region. So this is the question, what percent of company sales comes from each region? And for that we have this particular DAX formula. So let me copy this and put it over, create a new measure. I can paste it over here. Now you see, I want to see the region wise total percentage sales, and for that I have used this formula. Now let's understand how this formula works. See, we have the sales for current region, right? So we are saying the total sales, this is for the current region, whatever region you set. Okay, for example, if you haven't set any region, it will show you for all the regions. So that first of all we are getting this total sales. We are using a function called as divide because we want to see the percentage. Now divide is going to do like what we are going to divide. We are going to divide this total sales with this second value, and let's evaluate what is this second value. So first we will have the sales, and the denominator, you see we are using the calculate. So this is comma, after comma we have the denominator, whole is denominator. Now what we are doing inside the denominator, we are saying calculate what? Total sales, comma, I'm saying all customer region, right? So when you say all, and what you are passing? You are passing a column. So what it will do? It is going to remove filters only from that column, right? So I'm saying from the region column, you need to remove all the filters. That means all the regions should be present, right? And you are going to calculate the total sales on top of that. And then what we are going to do, we are going to divide by the total sales. So first we will have the total sales, and then with the help of calculate, we are going to calculate what? Region wise total sales, right? And then total sales, we are dividing it by the region wise sales. So for example, total sale is 100, but for north region the sale is 30. So 100 divided by 30 is going to give you the percentage. You can multiply this by 100 to get it in an actual percentage, right? Cool. So this is what the formula is. Now if I go over here and you commit this, and let me go to new page. So what name we have given? We have given the name region percentage total sales, right? So you have this. Let me drag and drop it over here, or what I can do, I'm going to create a donut chart, and in this donut I'm going to put region. So we have region inside the legends, so east, north, south, west, and region percentage sales I'm going to put inside the values. So now you see, let me expand this and go to the focus mode. So you see we have 29.79% of total sales coming from the west region, which is the our biggest region. Then we have east region, 24.56 percentage sales coming from here. Then we have south region, 23.94% sales coming from that region, and then from north region 21.72% sales are coming. So this is how you can interpret this. Now here what we have learned, like if you have some filters already applied, with the help of this calculate and all, see we are using all, so you can remove the filters, and then calculate is going to change the context so that you can grab the total sales without having any filter. Now point to remember is all and calculate always are going to work together. Okay, so see I have written here why calculate is required. So without calculate all cannot modify the context. So right, if you want to go and see on a row level wise, right, why row level wise, remember we need a total sales, right? So in order to get the total sales you need to go on each and every row. By the way, we have already calculated this total sales, so that's why it is not required, but even though if you need it you can do it, right? So that's why we require both these things. Without calculate all cannot modify the context, calculate is required to modify the context, right? And filter removal won't apply, all always works with calculate, right? So whenever there is going to be all, you need to use the calculate also. Let's take one more example, okay, it will be then more clear. Let's say for example global ranking I want to calculate. Now what is this global ranking? I want to rank my product by total sales across all the regions. So I'm going to use this product sales ranking. Let me copy this and go over here, and maybe I can do this. Okay, just give me a second. All right, so now I'm going to create a new measure and I'm going to copy paste this. So now this time see what I'm using rank X, and remember whenever you write X, that means it can work on a row level wise. It is nothing but this thing which we have learned. See over here, so it is a iterator, it can go and iterate on a row level wise, right? So let's come here once again, right? So we have created product sales rank. So we are saying we need to do the ranking, that's why this rank is required. Now we are saying rank X, that means we need to do ranking row wise. Now here what I'm saying all products product name. So whenever I am going to use all, that means it is going to remove all the filters from the product name. So I don't want any filter on the product name, and I need a total sales, which is I already have, and I want a descending order, and this dense I have used. So dense is going to give you the ranking, right? Since you are using this rank X, dense is going to give you unique ranking 1 2 3 dense, right? So dense ranking we are using. So this is how it works, it is going to create a ranking. Now let me commit this. If you come over here, how it works, you can read this. See, all is going to remove product filter and then makes ranking global. Then we have total sales, which is going to evaluate per product, and then we have descending highest sales rank 1, and then dense means no gaps in ranking. So this is how it's going to work. Let me cut this, and we have this product sales rank. Let me drag and drop it over here. So you see right now it is only showing one rank, but we want to see product wise ranking. So let's put product also, where we have product. Inside the product, here we have product name. So let me drag and drop it over here, and I can go to focus mode. And now you see we have product number accessory B, product name, which is on a 18th rank, and from left to right this is on the first rank. What is the first rank? We have widget D as our product name, which is on a first rank, right? Now let's say if I want to see the sales value also, so I can put total sales in this, and you see now this widget D is having highest sales, and that's why it is on rank 1. See, this is still on rank 1. See, it has the highest sales, and that's why it is on rank 1, and that's what we wanted, right? If you see this measure properly, let me click on this. You see we are removing the filters from the product name, we are grabbing the total sales wise ranking, right? That's what we wanted to see. So this is clear. Now this is, we have the global filter. Now when I let me put this thing, what I will do, I will take the region as a slicer or anything. Let's say if I click on slicer, this is filter, and I'm going to put region inside it. Now let me put region inside it. Okay, now right now we have widget D on the first rank. Now let me select any filter. If I select East, and as soon as I do this, do you see now on my rank 1 I have tech basics, because this East has already removed that previous, like what we have. We click on this, yeah, widget B, that product is not available inside the East region. So when you click East, tech basic is available, and that is on the rank 1. So this slicer or filter is changing the overall your ranking if you are applying this. Now let's say if I create this, okay, I will say global product sales rank, and this time what I'm going to do, I'm going to use calculate also with all. So let me create once again this new measure. Okay, I'm going to paste this. Now you see the difference is, here I'm saying remove the filters from product, but this time I'm saying calculate. So when you are going to use this calculate, so remember calculate, why it is used, it can remove the, see here we have seen calculate cannot work on slicers, so calculate can change the, see we have written calculate can change the context, right? It can change the context. So even though if you are going to apply the context from here, since you are going to use this calculate, it is not going to work now. Okay, so let me show you. We are using the calculate over here, and then here we are saying all customer region. So we are saying remove all the filters from the region, and now once we apply this region, it is not going to work. So let me check this. Okay, and this time first I will uncheck it. So this was the first earlier one, this one global product sales ranking, and this time what we have created this global product sales rank, right? Global product sales rank. Earlier what we have, earlier we have product sales rank only. So this one was, this is the product sales rank. Now let me drag and drop global product sales rank, and then we have this products. So let me put product name also here. So we have this, and then also sales amount, total sales, right? Let me put it over here. So now you see, let me do in this way. Alright, so now you see here we have widget D 620 is the total sales. Here also we have widget D 620 is the total sales. This is on a rank 1, right? So we have same data, but the difference is here we have used the calculate function, here we haven't used the calculate function. So now when you say East, you say, see here it got changed to tech basics, but here still widget B is on on the first rank. Now the data for which sales is not available inside the East region, they are gone, they are not displayed, but the ranking haven't changed. ranking wise we are still the same, but here it is got changed. Why? Because here we haven't used calculate. So whenever you are changing the context, see from here what you are doing, you are changing the context, right? Earlier it was the whole context. When you say row wise context, earlier it was there, but when you click on east you are setting the filter context, right? So when you click on east it is set as filter context, but since here you have set the filter context, since you have used calculate over here, it is changing once again to row wise context or row context. So calculate can change the context. That was the overall theme we have, right? So that's it. I hope you are able to understand little bit about DAX. If you are not able to understand, I recommend to repeat this lecture once again so that you will get the idea. These are our foundation of DAX. If you master this, you are not going to suffer, for the business scenario questions, which we are going to, take in the further lectures. Thank you.